In this video, we will be looking at angles in circles, and in particular, the fact that the angle at the center is twice the angle at the circumference. So suppose we've got a circle, there is an arc here at the bottom, so I will highlight this in red, and this is subtending an angle of size theta at the circumference. Now what we are saying here is that the angle at the center, the angle over here, is going to be twice the angle at the circumference. So in this case, the angle at the center is going to be 2 theta. Now, if this arc happens to be a semicircle, so we're looking at this scenario here, then the angle at the center is 180 degrees, which means that the angle at the circumference is going to be 90 degrees, which leads to this nice conclusion that the angle in a semicircle is going to be 90 degrees. Now we have to be careful every time that we are thinking of using this angle at the center being twice the angle at the circumference to make sure that we identify the arc which is subtending the angle. So one example is this one. So we've got this arc here which is subtending an angle of theta at the circumference, and therefore this angle at the center should be 2 theta. And the second example, which usually causes some difficulties, is this one here. We've got the major arc here which is subtending an angle of theta at the circumference, and notice that the angle at the center is this one. A common misconception would be for students to think that the 2 theta angle is going to be the one here. Try for the two angles to always be looking at the same direction, so theta with 2 theta. So let's give a quick example. We need to find, giving reasons, the value of x in this case here. We see that x is the angle at the center, 33 is the angle at the circumference, and therefore x will simply be 2 times 33, which gives an answer of 66 degrees, and the reason would be that angle at the center is twice the angle at the circumference. In these examples, we need to find the value of x, giving reasons. So it's good to start off by reminding ourselves that the angles in a triangle add up to 180 degrees, and the angles at the base of an isosceles triangle are equal. So in the first example, we have that we need to find x over here, and we are given that 50 is the angle at the base of this triangle. Well, we start by noticing that the triangle is isosceles because the two sides are radii. So if I call this angle here at the base y, I can simply say that y is 50 degrees. The reason is that angles at the base of an isosceles triangle are equal. And I can then proceed in finding the angle at the center, which I will call z. So z is equal to 180 minus 50 plus 50. This is giving a result of 80 degrees, and the justification would be that angles in a triangle add up to 180 degrees. And then to find x, I will simply say that x is 80 over 2, which gives an answer of 40. Notice that the 80 was the angle z at the center, so x is half of that because the angle at the center is twice the angle at the circumference. In the second example, we are given the angle at the center to be 88 degrees, the angle over here to be 50 degrees, and we need to find x. I will actually start by labeling the angle at the circumference here to be y, and we can simply say that y must be 88 over 2, which is 44 degrees. The reason is that the angle at the center is twice the angle at the circumference. And then if we call the third angle in the triangle on the right to be z, we can find z by doing 180 minus the 50 and the 44. This gives an answer of 86 degrees, and the reason is that angles in a triangle add up to 180 degrees. So we now know that x must be 180 minus 86, which turns out to be 94 degrees, and the reason now is that angles on a line add up to 180 degrees. For the proof, we start with a circle centered at O. We've got the arc AB, which subtends an angle of ACB at the circumference. I will start by drawing the radius from O to C, and we've got two triangles formed. on either side of OC. So I could call the angle OCB to be X and the angle OCA to be Y. So we start by noticing that the angle CBO over here, CBO is also X. The reason is that we've got angles at the base of an isosceles triangle, and similarly the angle CAO is also Y. Because we're constructing a proof, we need to provide reasons. So we've got that CBO is also X and CAO is Y. And the reason is that angles at the base of an isosceles triangle are equal. And then we can easily proceed into saying that angle COB over here is 180 minus 2x, because we know that angles in a triangle add up to 180 degrees. And similarly, angle COA should be 180 minus 2y. So let's write this down. COB is 180 minus 2x, and COA is 180 minus 2y. Let's write the reason, the fact that angles in a triangle add up to 180 degrees. And now we can conclude that the angle AOB, this angle here, I'm going to use the fact that angles at a point add up to 360 degrees. So it's going to be 360 minus the 180 minus 2y plus the 180 minus 2x. If I expand the brackets, I get 360 minus 180 plus 2y minus 180 plus 2x. We can see that the 360 with the minus 180 and the minus 180 will cancel out, and I get 2x plus 2y, with the 2 factoring out to give me 2 brackets x plus y. The reason here is that angles at a point add up to 360, and therefore we have just shown that if the angle at the circumference is x plus y, then the angle at the center, this angle here, is 2 brackets x plus y, and therefore this means that AOB is 2 times ACB, and therefore angle at the center is twice the angle at the circumference. Thanks for watching. If you found this video useful, please like it and subscribe to our channel. You can also leave a comment below to tell us what you think.